All right, today we're doing 5.1. We're going to review exponential equations for the next 2 days. Then we're going to move on to something called logarithms, which look really frightening, but they're actually not bad. So, exponential equations. Turns out they're very similar to linear equations. So y equals mx plus b. Let's say my mom decided I needed an allowance, and I looked in my piggy bank today, day 0, and there are $5 in my piggy bank. Every day, my mom gives me $2. So after 1 day, I would have 7, and after 2 days, I would have 9. What equation represents this situation? Two x plus 5. Because my $5 are increasing by $2 per day. And if I were to graph that, I would start at 5, and the slope would be up 2 over 1, and it would look like that. Okay? Well, let's say that I had a different equation. I start with $5, but this time, instead of going up by $2, I doubled my money every day. So day 1, there would be $10. Day 2, there would be 20. Day 3, there would be 40. Right? And notice, the first day I gained $5, and the second day I gained $10, and the third day I gained $20. What is that graph going to look like? It's going to look like this. That is an exponential graph. Okay? What would the equation be? Well, the exponential equation is y equals b times m to the x. So it would be y equals my original $5 that is doubled every day. Okay? And I could do a graph over here where I subtracted 2. So we would get 3, 1, and then that would be negative 2. Addition and subtraction are opposites. Well, multiplication and division are opposites, but when we deal with exponential equations, we don't want to multiply and then divide. We always want to multiply. Is there a way to multiply that's equivalent to dividing? You multiply by a fraction. So let's say that I look in my bank today, and there are $243, and I spend 2/3 of those dollars, so I only have 1/3 of my money left. So that would be 1 and 81, 2 and 27, 3 and 9, 4 and 3, 5 and 1, and 6 and 1/3. So the process is divide by 3, but I don't want to represent it as a division. I want to represent it as a multiplication. So here's what I do. Y equals 243 times something to the x. Yes, the equivalent of dividing by 3 is multiplying by 1/3. Okay, what is that graph going to look like? Okay. Wow, what did I do? And it turns out that exponential growth equations have the same general shape as exponential decay equations. Right? Now, one word we have to make sure we understand is this line here. Am I ever going to run out of money if I times by 1/3 over and over and over and over? No. I will never technically have $0. But practically, there is a point when I kind of run out of money. When would that be? Right, so I have $1. What's going to happen to my dollar the next day? It's going to be 33 cents. What's going to happen the next day? It's going to be like 11 cents. Then what's going to happen? It'll be like 3.5 cents. And then like 1.5 cents. But once I get below 1 cent, how do you spend less than 1 cent? You can't. You go to the bank and you say, hey, I want my 1/2 of a cent. And they say, sorry, we don't make halfpennies anymore. Those are gone. So technically, you will never run out of money. But practically, there's a point at which you don't have any money. Does that make sense? So will the graph ever touch the x-axis? No. But eventually, the distance between the graph and the x-axis is going to be so small that we either can't tell or we just quit caring. Right? So this line is called an asymptote. Yeah. And asymptotes are going to show up later in the year again. But with exponential equations, the x-axis is always an asymptote. Okay? All right. Let's do this. What if I have $8 and I want to increase it by 25%? How do you do that? It is 10. What math do you need to do to calculate that? So we don't want to divide. We want to multiply. Oops. Then what? Then you add it to 8. So if I have $8 and I increase my $8 by 25%, I end up with $10. So here's what I did. 8 times 0.25 plus 8. But I'm lazy. Is there a way to do that exact same calculation in one step instead of two? Eight plus 8. So I want to end up with 10. So this is 10. But I had to do two steps. I had to do this step, and then I had to do this step. Is there any way to skip the second step and just go straight from 8 to 10? Well, I mean, that would end up being two steps as well. Can we jump straight from 8 to 10? Yes. Is there a number we can multiply by that will do this step and this step together? Well, do these share any factors? An 8. So let's pull an 8 out. And I get 8 times what? If I take an 8 out of this, I get 0.25. What if I take an 8 out of this? I get 1. So that would be 8 times 1.25. Would that work? Yeah. Plug that in your calculator. 8 times 1.25 is 10. Why does this work? What's going on there? Well, it's saying keep 100% of your 8 and add an additional 25% to your 8. Does that make sense? So how would I go up 3.5%? 8 times, not 4.5. Remember, it's 100% plus 3.5% would be 1.035. Right? How would I go up 60%? 1.6. 1.6. Everybody see that? Okay. How would I go up 105%? 2.05. 2.05. Okay. What if I wanted to go down 10%? Ah, good. 90%. So it'd be 0.9. So to go down 10%, let's go through the calculation. So if I had $8 and I times it by 0.1, so to calculate how much money I would have if I lose 10%, I would take $8 and I would subtract 10% of $8. If I factor out the 8, I get 8 times 1 minus 0.1, and I get 8 times 0.9. So multiplying by 0.9 is the same as shrinking 10%. So think of, you have your stack of money there. You're going to keep 90% of it, and you're going to throw 10% of it away. Okay? All right, let me pull up our Alex. Yeah, oh, you're stretching. It's not a question. All right, 5.1. So in 5.1, here you just need to fill out a table. What is 4 to the negative 2? What is negative 4 to the negative 1? Fill that out. Piece of cake. Okay, graphing an exponential function. Let's actually go with, let's do the easy one first. Right here. So this is saying graph 4 to the x. And actually, it's y equals 1 times 4 to the x. So where does this graph start? How much money's in the bank account? So this is the start, and this is the increase. So this one starts at 1, and then multiply it by 4, multiply it by 4, and then it's going to go off the page. Okay? How would I figure out negative 1? Well, just put negative 1 in there. So it'd be 1 times 4 to the negative 1, and you get 0.25. So we need to graph the point negative 1, comma, 0.25. But when I try to graph that point, it won't let me. How do I graph a point that won't snap on there? You click this, and then you type in negative 1 for the x and 0.25 for the y. And you have to graph 5 points. Once you have all 5 points graphed, then you push the connect the dots button, and it will draw your line. Okay? But sometimes when you go to graph, so we might have something like this, y equals 2 times 3 to the x. So that's a pretty easy graph to draw. You start at 2, and then 2 times 3 would be 6, and then 18, right? And then you graph some points over here. But what if I make the x negative? So anything that happens to the x changes all the x values. So if I took all the positive x's and turned them into negative x's, and I took all the negative x's and turned them into positive x's, what effect is that going to have on the graph? It's going to flip across the y-axis. So even though this looks like an exponential growth, right, this suggests that we're going to graph that. That negative x is going to flip it across the y-axis, and the graph will actually look like that. And you can just plug in points. So use your calculator. So make a table, plug in 1, well, plug in 0. So we plug in 1, well, anyway, it'll be a decimal, but So you're going to plug in numbers, but know that even though this looks like a growth equation, that negative x is going to turn it into a decay equation. Okay. What if the negative is on the outside? That's going to take all the positive y's and turn them into negative y's. So the graph would look like this. It would be upside down. Okay. And on some of the questions, I'll show you. On these questions here, it wants you to graph the asymptote. And the asymptote is always on the x-axis. So on some of them, you just have to graph it. And some of them, you have to graph it and then put the asymptote, which is the x-axis. Yes. I stuck that there. That is the line of the asymptote. That's the line that the graph never touches. So will these have a vertical asymptote? No. There are vertical asymptotes, but not for exponential equations. Okay, so you will never use that button. You will always use the horizontal one. Okay. Let's do this. We have a car that how much did we pay for this car? If the equation is 24,500 times 0.86 to the t, we paid 24,500 for this car. Okay? Is the value of the car increasing or decreasing after we buy it? Decreasing. How do you tell? Our multiply value is less than 1. How fast is the value of the car decreasing? 86% represents how much of a loss? If we get to keep 86% of the car's value each year, how much of the car's value did we lose? 14%. So every year, we are going to lose more and more of our car's value. Is the amount we lose going to get bigger or smaller? Smaller. If we look at the graph, so the graph's going to look like this, right? The first year, we're going to lose, I don't know, $3,000. The next year, are we going to lose $3,000 again? No, we're going to lose like $2,700. Why? Why does the loss get smaller? So we're multiplying 86% by a smaller number. Up here, we started with 24,000, and we lose a certain amount. But now the car is worth less, and 86% of a smaller number is going to be smaller than the original amount. So our equation, we need to plug in 13. So 24,500 times 0.86 to the 13th. 24,500 times 0.86 to the 13th. Our car, after 13 years, is worth $3,448. If you buy a brand new car, well, this isn't the case anymore. If you go buy a brand new truck right now, if you can find one, you can turn around and sell it for more than it's worth, which is weird. But other than the last couple years, you go buy a brand new $30,000 car, it loses $5,000 of its value as soon as you drive it off the lot. Yeah. Cars are not good investments because the value of them shrinks. But you need a car, right? Most people do. I guess there are people in big cities that don't own cars. I don't need them. Let's ride the bus, subway, walk, Uber. Bicycles, electric scooters. All right. So this one says decrease, but I want to increase. So we have a forest that's growing. We start with 24,000 square kilometers. How do we increase an area by 5.5% every year? What would we multiply by? So it's 100% plus 5.5%, 1.065 to the 15th. Or it should be 5.5. You guys kept saying 6 and you confused me. There we go. All right. All right, that's it for today. Okay, tomorrow we're gonna spend a couple days doing some worksheets with finance, and then we'll be back to the Chromebooks later. But finish 5.1. Get to work.